If by now you are not yet amazed by the superpowers of hardware breakpoints, I want to show you another example. Let's open undergroundstring.asm. This program is pretty short and simple. By the main comment of this program, we know that this program only prints a string to the console. Let's take a closer look. This program contains two sections. The data section, which contains this string called follow, which contains follow me. And then the text section, which contains only a few instructions. Move ESI follow, and then call print star. This program is just going to print this string to the console. Nothing special here. Let's save this program and then assemble it. Let's run it just to make sure that we have the correct effect. And indeed we have this string printed to the console. Follow me. Now let's open this program with WinDBG. I pick undergroundstring.exe. We got undergroundstring.exe paused, and the debugger is waiting for commands. As usual, let's begin by putting a breakpoint on the entry point. Next, we use the go command. We add the disassembly window, and as expected, we can see that we stopped exactly on the first instruction. Move ESI and some offset. Let's step one instruction so we can get the location of the follow string. It is currently inside ESI. We can check the value of ESI and we get this number, which points to the follow string or maybe to the beginning of the data section. Those two things are just the same. Let's see the contents of the memory at location ESI. We use db command. We can see the string here. And this is the ASCII representation of the string. Just as a side note, we could use instead DA, which stands for display ASCII. Then we would only get the string. As we can see, the next instruction is call print star. Let's say for a moment that we want to find out something strange. We want to find out what is the first instruction that actually reads the string. The first instruction that really reads the follow string. We know that our code does not contain any such instruction, which means that this instruction is probably in some other piece of code, maybe inside training.inc, or maybe in some other module, for example. We could not really use software breakpoints to do this task. We have to use a hardware breakpoint. Let's try, for example, to find the first instruction that reads or writes to this location, to exactly this byte, which is L. We use the BA command to do this. BA R1 because we want to detect either reading or writing to this location of size 1. Then we supply the address, which is basically ESI plus 2. ESI contains this address, then ESI plus 1 is this byte, and the next byte is at location ESI plus 2. This is the wanted byte. We press the return key. Let's see the current list of breakpoints. This is the entry point breakpoint, and the next one is the hardware breakpoint, which we've just added. Next we use the G command, and we are going to find out where is the first location where this byte is read or written to. And interestingly enough, we got to a very strange place. We got to some instruction. By now we know that we should really take a look at the previous instruction, at this instruction. To verify that we really had an access to the specified location, let's find out what is the current value of ESI. It is this value, which is exactly the address of this byte. You might be wondering, what is this place? How come we have this code if we didn't written it? By reading this line, we can infer that we are inside MSV CRT module. This is just a DLL file. We can see here its name, msvcrt.dll. Let's take a look for a moment at the memory map to find out if we really have this module. We use the lm command to list the modules in our program. We can see here the MSVCRT module. We can also see that this address is really inside this range of addresses, inside MSVCRT. If we take a few moments to inspect this code, we can really see that in the beginning our byte is read from location ESI into AL, then it is copied into some other location, and next it is tested. This code checks if it reached a null terminator, and we can infer those conclusions only by looking at a few instructions. An interesting question would be, will this location in memory, this location of the byte that we have checked, is going to be accessed again after this access? In order to check it, we just have to use the go command again. Then we will be able to find out if there was another access or not. We can see that the process has ended. As we can see here, the function anti-DLL, anti-terminate process, was called. This means that this byte was never accessed again. Summary of this lesson. We use the BA command to find the first instruction that accesses our string, or maybe more specifically, the third byte of the string. Even though we don't know anything about the code that deals with our string internally, we can still find it using hardware breakpoints, which makes hardware breakpoints a very powerful tool. This is something, for example, that we could not do using a software breakpoint. We reached the end of the breakpoints chapter. If you ever want to know more about using breakpoints inside WinDBG, make sure to read WinDBG's documentation. This documentation, as we noted before, could be found in this menu, Help, Contents. WinDBG is very well documented, so make sure to check it out.